Gallium is the AI metal nobody talks about, and this is the story of why one obscure semiconductor material turned into a geopolitical pressure point for the future of artificial intelligence. Most people connect the AI boom to NVIDIA chips, giant data centers, and soaring electricity demand. But underneath that entire system sits this little-known material called gallium, a metal now tied directly to semiconductor supply chains, power electronics, and the global fight over AI infrastructure. Gallium is not officially labeled the AI metal in scientific or government reports, which matters because the real story is more specific than that. The International Energy Agency, the U.S. Geological Survey, and the Department of Energy all connect gallium to data centers, semiconductor systems, and AI-related infrastructure, while China controls nearly the entire refined global supply chain, and that's what pushed this material into the spotlight. Most people had never even heard of gallium before export restrictions started making headlines. Despite that, the International Energy Agency now describes it as an increasingly important material for advanced computer chips and power electronics tied to data center hardware, which meant a relatively obscure mineral suddenly became connected to one of the fastest-growing industries in the world. What makes gallium unusual is the way it's produced. Unlike copper or iron, companies rarely open dedicated gallium mines because most of the world's supply comes as a byproduct from processing bauxite for aluminum production, while smaller amounts are recovered from zinc processing residues, according to the U.S. Geological Survey. That changes the entire supply story. Finding more gallium underground is not the main challenge because the bottleneck sits inside refining and recovery systems, and that's where the geopolitical pressure starts building. China currently controls roughly 98 to 99% of global refined gallium supply, according to USGS and IEA data, while the United States remains completely import-reliant for gallium consumption tied to semiconductors and microchips. A supply chain that concentrated is rare. The situation becomes even more complicated because the issue extends far beyond raw gallium metal. Reuters reported that China's export controls covered multiple gallium-related products, including gallium arsenide, gallium nitride, gallium phosphide, gallium oxide, and several other semiconductor compounds, which meant the restrictions targeted the advanced materials used throughout electronics manufacturing rather than just shipments of raw refined metal. That distinction matters because gallium's role inside the AI economy comes from compound semiconductors and power systems connected to advanced computing hardware. Gallium arsenide and gallium nitride already appear in integrated circuits, telecommunications systems, high-performance computing hardware, LEDs, laser diodes, photodetectors, and defense-related electronics. Gallium nitride specifically enables wide-band gap power electronics critical for 5G base stations, electric vehicle charging systems, and efficient data center power management. The Department of Energy also connects wide-band gap power electronics to AI-driven infrastructure because these systems can improve energy efficiency inside data centers and telecommunications networks, and that's becoming a major issue as AI infrastructure expands. Electricity demand is now part of the story whether companies want it to be or not. According to the International Energy Agency, global investment in data centers climbed to roughly $500 billion in 2024, while data center electricity consumption could more than double by 2030. The IEA directly described AI as the biggest driver behind that growth, which pushed companies to look for more efficient semiconductor and power management technologies throughout the entire hardware stack. That shift gave gallium-based technologies far more strategic value. None of this means silicon disappeared. The research makes that clear. Silicon still dominates the semiconductor industry overall, but gallium-based compound semiconductors occupy specialized roles where high-temperature performance and efficiency matter more, especially in advanced power electronics and certain computing applications. That nuance matters because the online version of this story often gets exaggerated. The stronger argument is not that AI chips suddenly became made of gallium. The real argument is that AI infrastructure increased the importance of a highly specialized material with one of the most concentrated supply chains in the world, and governments reacted fast once they realized how dependent the market had become. Everything changed in 2023. On July 3, 2023, China announced export controls covering gallium and germanium-related products, and the restrictions officially took effect on August 1. Reuters later reported that Chinese exports of gallium and germanium products dropped to zero during the first month after the licensing system started, and that's when supply chain concerns moved from industry discussions into government strategy. European spot prices for unwrought gallium surged by 365% through 2025, highlighting the market disruption. Pressure increased again in December 2024. China's Ministry of Commerce announced tighter restrictions tied specifically to exports heading toward the United States, covering gallium, germanium, antimony, and other materials connected to advanced manufacturing supply chains. The result was a wave of new projects across North America, Europe, and Australia as governments and companies tried to reduce dependence on Chinese refining capacity, with many initiatives now receiving support under frameworks like the United States CHIPS and Science Act. Rio Tinto became one of the most closely watched examples. In May 2025, Rio Tinto and Indium Corporation announced successful extraction of primary gallium from material sourced at Rio's alumina refinery operations in Quebec. Rio Tinto later stated that a future commercial-scale facility could target around 40 tons annually, which the company said could represent roughly 5 to 10% of current world gallium production. Europe moved quickly too. Metlin announced a €295.5 million investment tied to bauxite, alumina, and gallium production in Greece, with a target of producing 50 metric tons of gallium annually. The European Commission later designated the project as a strategic project under the Critical Raw Materials Act, and by January 2026, the European Investment Bank approved €90 million in financing support. Australia entered the race through Alcoa and its partners. According to project materials released in 2026, the Alcoa Wagerup refinery project targeted late 2026 production with an expected capacity of 100 tons annually, though the research repeatedly emphasizes that these remain development stage or planned capacities rather than fully operating replacement supply chains. And that's the part most people overlook. Even though governments now want independent gallium supply, building it is far more complicated than opening a traditional mine because gallium recovery depends heavily on existing alumina and zinc processing infrastructure. USGS data also shows that capacity outside China already existed in some places, but often sat idle or underutilized, which meant the challenge involved economics, refining systems, and industrial processing capability as much as geology. That changed the government response completely. Instead of focusing only on mining expansion, countries started funding recovery systems, recycling programs, pilot facilities, and strategic stockpiles. The Department of Energy launched the Trace-GA initiative to help restart domestic primary gallium recovery in the United States for the first time in decades, while Reuters later reported that the European Union shortlisted gallium for its first joint critical minerals stockpile. Governments clearly see this as more than a small metals story. The AI boom now affects electricity systems, semiconductor manufacturing, mineral processing, data center construction, and geopolitical trade policy all at once, and gallium sits directly in the middle of those overlapping pressures. The metal itself remains relatively small in tonnage, but the systems connected to it are enormous. That's why gallium matters. Copper may represent the physical scale of the AI economy through wiring, power grids, and infrastructure buildouts, but gallium represents something different. Its importance comes from concentrated control, specialized semiconductor applications, and dependence on highly refined downstream processing that few countries currently dominate. That combination turned a little-known byproduct metal into a strategic supply chain issue tied directly to artificial intelligence. Gallium did not suddenly appear because of AI. Semiconductor industries have used gallium-based technologies for decades, but the rapid expansion of AI infrastructure pushed efficiency, advanced computing hardware, and power electronics into a much bigger spotlight, and that raised the strategic importance of the materials connected to those systems. Now, governments are scrambling to diversify supply chains that most people never realized existed. When people discuss the future of AI, they usually focus on software models, trillion-dollar technology companies, GPU, and data center expansion. Beneath all of that sits another race unfolding quietly through mineral processing systems, refinery projects, semiconductor compounds, and critical material stockpiles. And that race increasingly revolves around a metal almost nobody was talking about just a few years ago.